Hello, everyone. Today we will be giving a presentation on an element that you might be familiar with. But first, my name is Amanda, and today my team and I will be giving you a presentation on why you should care about nitrogen. To start, here are some fun facts about nitrogen that you might not have heard of. The first one is it's the most plentiful diatomic gas in the atmosphere, where 70% of the Earth's atmosphere is nitrogen. Have you ever heard of Night Creamery in San Luis Obispo? Night Creamery specializes in ice cream made of liquid nitrogen. When you arrive, you can see them prepare your ice cream using a liquid nitrogen machine. The Northern Lights in Alaska have nitrogen, which produces the red and purple lights. Now let's take a look at the discovery of nitrogen. Scottish physician Daniel Rutherford discovered nitrogen through isolating the nitrogen particles from oxygen and carbon dioxide. He experimented on a mouse by trapping it in a container of air and letting the mouse breathe in all of the oxygen. To ensure that he took out all the oxygen, he even burned a candle to make sure that all the oxygen particles were gone. What was left in the container was the nitrogen particles, which we now know as nitrogen on the periodic table. And unfortunately, this did end up suffocating the mouse. Now let's take a look at the nitrogen on the periodic table. So as you can see on the periodic table, which we are all familiar with, nitrogen has an atomic number of 7. It has 7 protons, neutrons, and electrons. Its atomic mass is 14.001 and has 5 valence electrons. Moving on to the chemical and physical properties.
I'm Brandon. I'm going to be further elaborating on the physical and chemical properties of nitrogen. The first one being its appearance, how nitrogen is a colorless element. Additionally, nitrogen is odorless and tasteless, and this applies to both gas and liquid forms. Nitrogen has a melting point of -210 degrees Celsius or -346 degrees Fahrenheit, and a boiling point of -195.8 degrees Celsius or -320.44 degrees Fahrenheit. Nitrogen has a density of about 1.251 grams per liter at 0 degrees Celsius, and this makes nitrogen slightly lighter than air. Now moving on to the chemical properties of nitrogen. Nitrogen is a nonmetallic element with an electronegativity of 3.04. Nitrogen is generally inert, which means it's not very reactive with other elements. And to further elaborate on the fun fact about nitrogen being responsible for the northern lights, ionized nitrogen is responsible for the orange-red, blue-green, blue-violet, and deep violet colors of the aura. And this is determined by the specific atmospheric gas and its electrical state, as well as the energy of the particles that meet with the atmospheric gas. Lastly, nitrogen is insoluble because nitrogen is a nonpolar element, which is insoluble in water because water is a polar solvent. Now moving on to the nitrogen cycle and how we use nitrogen in class.
I'm Sam, and I'll be telling you about the nitrogen cycle and about nitrogen in the classroom. Nitrogen makes up about 78% of the atmosphere in terms of volume. It is harnessed by microbes in the soil, bacteria, and certain algae in the process called nitrogen fixation. As a result of fixation, nitrates and ammonia are formed, which plants assimilate to their tissues through nitrogen assimilation. When animals ingest these plants, they also assimilate nitrogen. When organisms die, they are broken down by microorganisms, and the nitrogen in their remains is released through ammonification. After this ammonia is released, other bacteria break it down into nitrates in a process called nitrification. The nitrates are then utilized by even more bacteria in a process called denitrification, which releases the nitrogen from the nitrates back into the atmosphere. While this cycle seems rather streamlined, it's important to remember that the steps of the nitrogen cycle do not always fall in the same exact order. It is also interesting to see that every step of the cycle is only possible through an organism. In the classroom, edit this out. In the classroom, many will learn that nitrogen occurs in 2 main functional groups, amines and amides. In inorganic compounds, nitrogen is especially prevalent in polyatomic ions such as ammonia and cyanide. It is also present in covalent bonds such as nitrates and nitrites. In our own experience, we used ammonia in a hard water analysis lab to measure the hardness of water in several samples. Students in food science and meat science will also learn the importance of nitrates and nitrites in the preservation of certain foods, such as bacon. Now on to an application in real life.
Hi, I'm Peter. Now that we've seen the background of nitrogen, let's look at some real-life applications in which this amazing element is used. One of the most popular uses for nitrogen is refrigeration, specifically in its pure liquid form as mentioned earlier. From ice cream to preserving biological samples, liquid nitrogen is widespread, due in part to how simple it is to obtain. Prevalent in the atmosphere, a typical nitrogen generator can create a practically infinite supply. Another area in which nitrogen is valued quite heavily is within the agricultural industry. Nitric acid is combined with ammonia to create ammonium nitrate, which is one of the most popular nitrogen-rich fertilizers with use in all parts of the world. This substance helps expedite the nitrogen cycle mentioned earlier. In addition, ammonium nitrate serves as one of the most popular industrial explosives used extensively within the mining and quarry industries as a cheap base. Nitrogen purely as a gas has many industrial applications as well, with its inertness and uniform nature being incredibly useful. The latter of the two benefits are leveraged in the filling of tires, which extends its useful life by providing constant rolling resistance through a homogeneous mixture instead of the ordinary heterogeneous air. Nitrogen gas is also used in electronic and steel industries to purge unwanted gases from the procedure, its inert nature making it valuable to transport other substances. The same benefit is surprisingly used in the manufacture of chips. Nitrogen prevents the potato from going stale, while also providing protection for the product. Another important area in which nitrogen is important is in the world of biology and pharmaceuticals, proteins and anesthesia respectively. In fact, nitrous oxide, better known as laughing gas, is one of the most popular and safe forms of anesthesia in the world. In terms of biological processes, nitrogen is a key component for not only amino acids, the monomers of protein, but also play a key part in nucleic acids as well. I'd like to thank you for learning about nitrogen with us, and I hope you have a wonderful day.